This video covers integers that satisfy inequalities, solving one-step inequalities, and solving two-step inequalities. Before we get started, let's first identify what an integer is. An integer is a whole number that can be positive, negative, or zero. For example, the first 10 integers after 0 are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Numbers like 3.5, 1 over 3, or even pi are not integers, as they have decimal values. Now we have an idea what an integer is. Have a think about this question. What is the largest integer that satisfies this inequality? We know from this that the group of numbers are less than 9, so the largest whole number that is less than 9 is therefore 8. How about this inequality? List the first 3 integers that satisfy this inequality. Pause and have a think what the answer might be. The first 3 integers would be 11, 12, and 13, as the inequality is greater than or equal to. Or equal to means we include the value in the list. Quickly pause and have a go at these questions. Have a look at this inequality. List all the integers that satisfy this inequality. For this question, we are essentially looking for the whole numbers that lie between -5 and 2. However, not equal to either number, as the inequalities present are less than symbols. The numbers between these two numbers are as follows. Quickly pause and have a go at this question. Once again, we list the values between 7 and 10, but this time we include 10 as the inequality next to it is less than or equal to, but we don't include 7. The numbers are 8, 9, and 10. Pause and have a go at these questions. For the next series of questions, we have to have a good idea of how to solve one- and two-step equations like this. Just to recap, we solve for x by making the variable the subject by applying the same operation to both sides of the equal symbol. We subtract 4 from both sides to give us x equals to 9. For this question, we divide both sides by 4 to give us x equals to 5. And finally, in 2 steps, we add 4 to both sides, giving us 15, then dividing both sides by 3 to give us x equal to 5. The same solving process applies to these types of questions. Have a look at this question. Solve the inequality x plus 4 is greater than 13. Like in the previous example, we solve for x, but instead of an equal symbol, there's an inequality. Subtract 4 from both sides, which gives us x is greater than 9. This is our final answer. Pause and have a go at these questions. Just like before, we solve for x. Divide both sides by 4, giving us x is less than or equal to 5. For the second question, we add 4 to both sides, giving us 3x is greater than -15. Then divide both sides by 3, giving us x is greater than -5. For the last question, we multiply both sides by 3, giving us x is less than or equal to -12. Consider this question. List all the integer values for x such that 10 is less than x plus 4 less than 13. Like the example where we solve the equation by applying the same operation to both sides of the equal symbol, we do the same thing for all parts of the inequality until we only have x. We subtract 4 from all 3 parts and we get 6 is less than x, which is less than 9. Now we can list the values that are between 6 and 9, but not equal to 6 and 9, as the inequalities are just less than. We can check to see if the two numbers are true. We substitute 7 for x and then add 4 to it. We get 11. If we substituted 8 instead and add 4, we'd get 12. 11 and 12 are the only numbers that can be between 10 and 13 in this inequality. How about this question? List the integer values of x such that 4 is less than or equal to 4x, which is less than 20. We want to have the inequality where x is by itself, so we divide all 3 parts by 4, giving us the inequality of 1 is less than or equal to x, which is less than 5. The values of x are between 1 and 5 and include 1 as the inequality is less than or equal to. The answer is 1, 2, 3, and 4. Another example, 2 is less than or equal to 3x minus 4, which is less than or equal to 11. First we add 4 to all 3 parts, giving us 6 is less than or equal to 3x, which is less than or equal to 15. Then we divide all three parts by 3, giving us 2 is less than or equal to x, which is less than or equal to 5. The values that are between 2 and 5, including 2 and 5, are 2, 3, 4, and 5. Our last example. Minus 2 is less than or equal to 2x plus 3, which is less than 6. Subtract 3 to give us negative 5 is less than or equal to 2x, which is less than 3. We next divide by 2, giving us negative 5 over 2 is less than or equal to x, which is less than 3 over 2. In this case, it will be more helpful to convert the fractions into mixed numbers to see where the closest whole numbers are. Therefore, we get negative 2.5, which is less than or equal to x, which is less than 1.5. This means the integers of x are between just under negative 2 and just over 1. The answers are negative 2, negative 1, 0, and 1. To summarize, we use what we know about integers to identify numbers that fit within an inequality. When solving an inequality, solve as if you're solving an equation. The same technique applies when identifying values in an inequality, and you have to make x the subject. Change fractions into mixed fractions to identify the whole numbers that the values lie between.